Hi guys, Daniel here. Hope you're doing well. Hope you guys are studying hard as exams get closer and closer. So today we've got the GCSE Maths Edexcel paper, paper 1, foundation tier of summer 2023, so last year's paper. And yeah, I think it was a pretty okay paper. A couple of tricky bits for sure, which you guys will see. You guys will have the timestamps in the description, so you can easily go to whatever question you'd like. And yeah, that's pretty much it for me. So let's get into it. Okay, so question one says we need to write 38% as a decimal for 1 mark. Now remember, to write a percentage as a decimal, you need to write it as a fraction first. 38% is just the same as 38 divided by 100. And if I divide this by 100, that means I'm going to move the decimal place 2 units to the left, which should give me 0.38. So the answer is 0.38 for this one. That's question one. Question two says, what fraction of this shape is shaded? Well, this shape has been split into how many parts? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 parts, 3 are shaded. It has to be 3 out of 10. And that's question two. Question three says, here is a list of numbers: 1.6, 1.4, 2.1, 0.5, and 1.3. From the list, write down the smallest number. Now, clearly, the smallest number would be any number that's less than 1, which is 0.5, because every other number is more than 1. So it's going to be 0.5. Oops, not 0.15, 0.5. Apologies, 0.5. Okay, and we need to, for question four, we need to work out -9 plus 5. Now, -9 plus 5, just imagine you're on a number line. Let's say -9 is here. Let's say this is -10. Let's say this is -11. Let's say this is -8, -7, and -6, and blah, blah, blah. If I'm adding 5 and I'm at -9, that means I have to move 5 units to the right. So 1, 2, 3, 4, 5. That would be -5. That would be -4. So therefore, the answer to -9 plus 5 is just going to be -4. That's question 4 done. Now let's go to question 5. Question 5 says we need to solve p minus 2 is equal to 3. Okay, so remember, when you're solving an equation, what you want to do is just get the letter on its own. What I can see, I'll write it out here again. P minus 2 is equal to 3. We need to get this -2 away from the P to isolate it. And the way we do this is by doing the opposite. It's minusing at the moment, so I need to add 2 to both sides. So therefore, it's just going to be P is equal to 3 plus 2, which is just equal to 5. So therefore, P is equal to 5. And that is the first 5 questions finished. Okay, so question 6 says Freddie adds labels to this diagram of a circle. We've got the diameter, we've got the circumference, we've got the center. And the question says, explain why one of the labels is wrong. Well, remember, when you're dealing with a circle, what you should know is that any distance from the center to the circumference is labeled the radius. That the diameter goes from one end all the way through the center to the other. So this is wrong. This should be the radius. So all you'd have to say is the diameter should be labeled the radius. And that's it for question 6. Let's move on to question 7. Now, question 7 says we need to write down 3 different factors of 20. So you only need 3. So what I'll do is I'll just list all of them. So we know that 1 would be a factor, 2 would be a factor, 4 is a factor, so is 5, so is 10, and so is 20. So these are all of the factors of 20. We just need 3 of them. So I'll just choose the first 3. 1, 2, and 4. And that will be it for question 7. Okay, so question 8. So we've got a diagram here. We've got an angle of 50 degrees and we've got another angle marked X. And part 8 asks us to work out the size of the angle marked X. Now, we've got 2 angles and they are about a point. What you need to remember is that angles about a point, they add to make 360. Meaning that this angle of 50 degrees, plus the angle of X degrees, this must make 360 degrees. Meaning that our X would just be equal to 360 degrees, take away 50 degrees, which is quite clearly 310. So therefore, X is just 310 degrees. So that's part A. Part B says, a student says that an angle of 50 degrees is an obtuse angle. The student is wrong. Explain why. because an obtuse angle is just an angle which is greater than 90 and less than 180. So that's all you need to say here. An angle of 50 degrees is an acute angle. So you could just say either one of those two. I'll just say the angle, the angle, the angle of 50 degrees is an acute angle. An obtuse angle would be more than 90 but less than 180. So either one of these two sentences will give you the mark. And yeah, that's question 8 finished. Okay, so question 9 says, well, we've got a graph given to us, and we've got 2 points A and B, and we've got a line in between, and part A says we need to write down the coordinates of point B. Okay, well, point B is right here. We can see along the x-axis, right, that's going to be a 5. And along the y-axis, we can see that that's going to be a 2 right here. So therefore, the coordinate of point B would just be x equals 5 and y equals 2. Remember, x goes first, y goes second. Now, part B says we need to plot the point with coordinates 4, -2 and label this point C. Now, where is the point 4, -2? Now, remember, x goes first, so we need to look along the x-axis first, which is going to be right here at 4. And then -2 means we just go down by 2. So therefore, this right here will be the point C. And that is the coordinates 4, -2. Okay, so that's done. Part C says we need to write down the coordinates of the midpoint of AB. So that's just halfway between each of the points, which we can see quite clearly. Halfway between these points will just be right here, wouldn't it? Right? Because you go down and then to the right by 4, and it's the same thing here. You go down and then you go to the right by 4. So it's definitely this point here, and this is the point 1, 3, isn't it? So therefore that will be the point 1, 3. I'll just do it in navy blue. Or do the point 1, 3. Now, part D says we need to draw the line y equals -4. Okay, now whenever they ask you to draw a line, right, and I'll just give you two things here. So if they ask you to draw a line of x equals k, right, this is just a vertical line. Sorry, let me get an actual vertical line. This is just a vertical line through that point on the x-axis. And if they ask you to draw y equals k, this is just a horizontal line through that point on the y-axis, right? So in our case, they've asked us to draw the line of y equals -4. So y equals -4 on our y-axis will be right here. So all we're going to do is just draw a horizontal line through that point, which is going to be like this here. And this is going to be y equals -4. And that will be it. And that is question 9 finished. Okay, so question 10 says, Max sees this special offer in a shop. Buy one large plate and get one small plate for half the normal price. The normal price of a large plate is £2. The normal price of a small plate is 80p. Max wants to buy 6 large plates and 6 small plates using this offer. He has £15. Has Max got enough money? You must show how you get your answer. Okay, so we've got a bit of a deal going on here where we've got one large plate and one small plate. And if you get one large plate, let's actually see what they're saying. So if we get one large plate, I'm going to write one large for one large plate. We know that this is equal to £2. And we know that one small, this is equal to 80p. But there's a deal going on, right? And let's see how much the deal would cost for one of each. The deal states that if you get one large plate, right? So I'm going to write one large. This is equal to £2 still. You will get one small plate for half the price. So in this deal, the small plate is actually going to be half the price. Half of 80 is just 40p. So I'm going to put 40p here. And this is the deal for one large or one small, right? Now, Max wants to buy 6 large and 6 smalls, meaning that we want 6 of this deal. So let's add the total to see what the total would be. Total would be just £2, right? Plus the 40 pence, which I'll write like this. And this is just going to equal £2.40. So therefore, we could say that, well, one deal is equal to £2.40. And we know that Max wants 6 of this. So to work out how much it will cost Max, we just need to multiply this by 6. I'm going to write 6 deals will just be equal to 6 times the £2.40. So all we need to do is work this out and see whether or not it's more than or less than his money that he has, which is £15. So let's go ahead and do this. So I'm going to use the column method. So let's say I have £2.40. I'm going to times this by 6 here. Now, we know that 6 times 0 is 0, so we're going to put a 0 here. 4 times 6 is 24, so I'm going to put the 4 here, and I'm going to carry the 2 here. And I'm going to have to put a point here, isn't it? Because there's a point here. Now, 6 times 2 is 12. I'm going to add that 2, that will give me 14. Meaning that the total amount for 6 deals is just going to be £14.40. So I'm going to say 6 deals here is just equal to £14.40, which is less than how much money Max has, which is £15. So the answer is yes, Max has enough money. So always remember to write a yes or no, because they were asking you a question. So you just say yes, Max has enough money. Enough money. And that will be question 10, and that will give you the 4 marks. Okay, so question 11 says a total of 700 tickets were on the sale for a football match. 452 of the tickets were sold. How many tickets were not sold? Okay, well, if we have 700 tickets and 452 were sold, that means that the amount that weren't sold would just be 700 take away 452, the remaining. So what we're going to do is just subtract. We're going to do 700 take away 452. I'll use the column method. Now we can't do this because it's too small. We can't do this. We have nothing to borrow here. So we have to borrow from the 7. So I'm going to take 1 away. This will be a 6 here. And then that one will go there. But now I still can't borrow from this one. I still can't subtract this one. So I'm going to have to borrow from this one again. So it'll be this. That will turn into a 9. I'll put a 1 here. And now we're in a position to... Well, now we're in a position to start subtracting. 10 take away 2 is 8. 9 take away 5 is 4. 6 take away 4 is 2. So the amount of tickets that weren't sold is just 248. And that is part A. Now part B says for a different football match, 297 tickets were sold for £9.50 each. 399 tickets were sold for £19.50 each. Part B says work out an estimate for the total amount of money paid for these tickets. You must show all your work in. Okay, now this is a non-calculator paper and it's an estimate question. So what they want you to do is just round your values. And what you can do here, so we've got 2 pieces of information. I've written number 1 and number 2. So I'll say for number 1, we know that we have 297 tickets. And we know that each ticket is being sold for £9.50. So I'm going to write 1 ticket is equal to £9.50. What you want to do with this one is you want to round these values. Remember, this is a non-calculator paper. They don't want the actual answer. So you're going to round these to the nearest 100 here and the nearest 10, just to make it easier for yourself. So I'm going to round this to 300. So I'm going to write 300 tickets instead. And we're going to say that one ticket is just going to cost us £10. Meaning that the total for this one, well, if one ticket is £10 and there's 300, then we just have to multiply the 300 and the 10. So it'll just be 300 times by 10. This is going to equal 3,000, and this would be in pounds, isn't it? So that would be the total cost as an estimate for the number of tickets sold, the amount of money made for the first match. Now, the second match, what do we know? We know that there were 399 tickets here, and then we know that one ticket is being sold for £19.50. Again, we need to round. So I'm going to round this to the nearest 100, which is going to be 400 tickets. And we're going to say that this is being sold for, so not £19.50, but we're going to say to the nearest 10, which is £20. Now, if that's the case, then the total for this one is just going to be equal to the amount of tickets, 400 times the price per ticket. So it's going to be 400 times by 20, which will just be 4 times 2 is 8, and then add on the zeros. So 1, 2, 3, and this will be £8,000. Meaning that the total cost is just going to be the 3,000 plus the 8,000, which is just 11,000, isn't it? So the answer is just £11,000. And that will give you the 3 marks. Now, part C says, is your answer to part B an underestimate or an overestimate? Give a reason for your answer. Now, remember, it's definitely an estimate because we rounded. Now, remember, we actually rounded up in each scenario, we rounded the amount of tickets up to 300 here. We rounded the amount of tickets up to 400 here. And we rounded the price up to 10 and the price up to 20. So we rounded up in each scenario, meaning that our estimate is actually going to be more than the true value because we've rounded up the amount of tickets we're buying and the cost of it, meaning that it's going to be more. So therefore, we're just going to say it is going to be an overestimate, since we rounded up the number of tickets and the price per ticket. And that will give you the 1 mark. And that is question 11 finished. Okay, so question 12 says, here are 6 numbers, 13, 5, 4, 9, 3, and 8. And we need to work out the mean. Now remember, to work out the mean, you need to remember this. It's very, very simple. This is just always equal to the sum of all of the numbers, right? Sum of all numbers. We're going to divide this by the amount of numbers that we have here. So in this case, what we could say then is that we're just going to add these. So it's going to be 13 plus 5 plus 4 plus 9 plus 3 plus 8. And we're going to divide this by how many numbers there are. 1, 2, 3, 4, 5, 6. And they also told us as well. So we know it was over 6 anyway. So let's work out the numerator. Now, let me just get a nice fraction bar. I'll do it bit by bit. 13 plus 5 is 18, right? And then I'm going to do the 4 plus the 9, which is 13, like this. And I'm going to do the 3 plus the 8, which is 11. This is all over 6, right? Now, let me just make the fraction bar a bit smaller. Okay, now let us continue. Now, 18 plus 13, right, is going to be equal to 10 and 10 is 20. This is going to be 31. It's going to be 31. 18 plus 13 is 31. And I'm going to add an 11 like this here. 31 plus 11 is just 42. 42 divided by 6, you should know your times tables. This is just 7. So therefore, the mean is just 7. And that's it for question 12. Okay, so question 13 says we need to simplify 15a divided by 3. Now, the way you simplify algebraic expressions is you kind of ignore the letter in this case. So we've got an a here, right? And then I've got 15 divided by 3. What you want to do is work out what that is. 15 divided by 3 is just equal to 5. So therefore, that there will simplify to 5. And then we have this a which is being multiplied. So the answer is just going to be 5 because 15 divided by 3 is 5, and then we've multiplied by a. So therefore the answer is just 5a. So that would be this one here, 5a. Now part B says we need to simplify 19 plus 5b plus 4c minus 7b plus c for 2 marks. Now this one here, you're just collecting like terms. So when I always teach this to my students, I always highlight the different parts. So I've got a number here, which I'm going to highlight in yellow. I don't have any other numbers here in the sense where there is just a number. There's no letters multiplied. So I'm just going to keep that. Now I can see that I've got a plus 5b. And then I've also got a minus 7b. So I'm going to highlight that there. And then that will leave the c's, which is a plus 4c plus a c, right? So now all I'm going to do is work these out individually. Now this one is 19. That's going to stay as 19. That's fine. The next one in blue is going to be 5b, right? Minus 7b. Now that's just the same as 5 minus 7, which is just minus 2. So it's just a minus 2b. And then the last one is 4c plus c. This is just 5 lots of c altogether. So all of these here, I'll highlight them again. So I've got 19. I've got minus 2b. And I've got 5c. This is going to be our final answer. We're going to just bring these all together in one line. So it's going to be 19, take 2b plus 5c. That is our answer. Now that's done. Part C says we need to factorize 8d take away 6. Now remember, when you're factorizing, you are looking at both of your terms and you ask yourself, are there any common factors? And there is one here because I've got 8d and I've got a minus 6. right? We can see that if I look at the number part of both of these terms, we can see a common factor of 2 coming from the 8 here, and a common factor of 2 coming from the 6 here. So we can actually pull out a 2. And then remember, whenever you're factorizing, you just need to ask yourself, what do I need to multiply to get back to where I started? So I'm at 2, and I need to multiply something to get me to 8d. Or to get the 8, I need a 4, and then I just need to put a d here. 2 times 4d is 8d. That's perfectly fine. And then we have a minus. And then how do I go from a 2 to a 6? What do I multiply 2 by to get me to 6? That's just 3. So therefore, we have 2 bracket 4d minus 3. So the answer is 2 bracket 4d minus 3. And what you can always do as well is you can always expand this and see if you get what you started with, and that will let you know you've done it correctly. And yeah, that's question 13 finished. Okay, so we've got question 14. It says last week, 73% of the tickets sold at a cinema were adult tickets. What percentage of the tickets sold were not adult tickets for part A? And well, if 73% were adult tickets, then not adult tickets would just be 100% take away 73%. So you're just going to do 100 take away 73, which is just equal to 27. So the answer is just going to be 27%. Now, part B says some people watch the film at the cinema. The number of adults to the number of children is in the ratio 2 to 5. What fraction of these people are adults? Now, remember, with ratios, right, what you're doing is you have this total quantity and you're expressing it into parts. So what we're saying here is that the adults, I'm going to write adults will have 2 parts based on this ratio. The children will have 5 parts. And there are a total of 2 plus 5, 7 parts. So I'll say total is 7 parts, right? Meaning that the fraction of people that were adults will be the amount of parts that were adults divided by the total amount of parts. So that's going to be 2 out of 7. So that will be part B. Now, part C says on Friday, 500 people watched the film at the cinema. 70% of these people were children. On Saturday, 720 people watched the film at the cinema. 5/8 of these people were children. Kasim thinks more children watched the film on Friday than on Saturday. Is Kasim correct? You must show how you get your answer. So all we need to do is just work out how many people watched the film on Friday. Children. Work out how many children watched the film on Friday. Work out how many children watched the film on Saturday, and then just compare. So let's start with Friday. What do we know about Friday? We know that there were 500 people, so I'm going to write total is equal to 500. And we know that there were 70% that were children. So what we need to do to work out how many children watched it on Friday is just work out 70% of 500. Now, we don't have a calculator, so what I like to do is write the total as a percentage, which would be 100. So I can say that 100% of people would be the 500, meaning that, well, remember, you want to get to 70%. So what you could do is figure out what 10% is, and that's quite easy because you're just going to divide by 10. So this will give us 15. And then now we need to times by 7 to get to 70%. So we divide it by 10 first, and then we times by 7. Now, 50 times by 7, well, 5 times 7 is 35, and then you just add the 0 on. So what we know now is that there were 350 children on Friday that watched this film. So that one is done. We know that there were 350 children on Friday, so now let's deal with Saturday. So what do we know about Saturday? Well, there were 720 people in total on Saturday, right? And 5/8 of these people were children. So what we need to work out is just 5/8 of 720 because that's the amount of people that were in the cinema. Now, what I would do, this is a non-calculator paper, what I would do is work out what 1/8 is. 1/8 of 720. And then once I work that out, I just times it by 5. And that will give us 5/8. Now, how do we work out 1/8 of 720? Well, that's just the same as doing 720 divided by 8. Now, what I could do is use the bus stop method. So I'll do this here, 720. Now, how many times does 8 go into 7? It doesn't. How many times does 8 go into 72? This is something we should know from our times tables. 8 goes into 72 9 times, right? 8 times 9 is 72. So I'm going to put a 9 here, and then there's a 0 there, so I'm going to put a 0 here. So therefore, this is just equal to 90, meaning that 1/8 of 720 is 90. Remember, we need 5/8, though, don't we? So we're going to just say that 5/8 of 720, right, is just going to equal the 90 times by the 5. Now remember, 9 times 5 is 45, so this is just going to be 450. So now we know the amount of children that watched the film on Friday, 350, and the amount of children that watched the film on Saturday, 450. Let's go back to what Kasim said. Kasim thinks that more children watched the film on Friday, sorry, than on Saturday. Is Kasim correct? Well, she's clearly incorrect, right? Because there were 350 people, 350 children that watched the film on Friday, and there were 100 more on Saturday. So all you have to do here is just say, no, she is incorrect, as 350 is less than 450. And that's it. And that will give you the 3 marks for question 14. And this is the entire of question 14 finished. Okay, so question 15 says we need to work out 6 over 7 multiplied by 5 over 12, and we need to give our answer as a fraction in its simplest form. So there are two ways to do this. I'll show you both ways. So we've got 6 over 7. We're multiplying this by 5 over 12. Now, what I would do is you can just multiply across, can't you? So we're going to do 6 times 5, which is equal to 30. And then 7 times by 12, what you can do, you may know it off by heart, but you can just use the column method just in case you don't. So let's go ahead and do this. 7 times by 2 is 14. So I'm going to put the 4 here, carry the 1 here. 7 times 1 is 7, add the 1, that's 8. So it's 84. So therefore, this is equal to 30 over 84. However, it says we need to give our answer as a fraction in its simplest form. So can we simplify this? We can. They're both even numbers, so we can divide by 2. If I divide the top by 2, I'll get 15. If I divide the bottom by 2, this will give me 42. Now, 15 and 42, do these have any common factors? Yes, they do. You can divide the 15 by 3, and you can divide the 42 by 3. Again, having a good knowledge of your times tables is really important on a non-calculator paper. 15 divided by 3 is 5, and 42 divided by 3 is 14. You could just use the Buster method to double check. Yeah, so the answer would be 5 over 14. And this is one way that you could do this. Now, another way that I like to do as well is before I actually start to multiply across, I check to see if I have any factors top and bottom, any numbers top and bottom which have a common factor. And it doesn't have to be directly below. Just one has to be on the top, one has to be on the bottom. Now, what I can see here is that I've got a 6 here and I've got a 12. I know that 6 goes into 6 once, right? And 6 goes into 12 twice. So this fraction has been simplified. 5 and 7 don't have any common factors. So I could actually write this as 1 over 7 times by 5 over 2. And then in this case, we can just multiply across a lot more easier than we did on the top here, which is just going to be 5. 1 times 5 is 5. 7 times 2 is 14. So the answer is 5 over 14. The exact same thing we got here, but this way is a bit more efficient. But it just depends, completely up to you what you prefer. I know a lot of my students prefer doing the top way, which is absolutely fine. I just thought to show you both just in case. But yeah, that's question 15, finished. Okay, so question 16 says, here is the list of ingredients for making 20 biscuits. We've got 150 grams needed for butter, 100 grams needed for sugar, and 250 grams needed for flour. Harry wants to make 60 biscuits. How much flour does Harry need? Okay, so we've got 3 ingredients here, but they're only asking us for one of the ingredients, which is flour. So what I would do is say, okay, well, fine. I'm going to say that for 20 biscuits, right? For 20 biscuits, we know that in terms of flour, we need 250 grams. So I'm going to 250 grams of flour. Okay. Now we need 60 biscuits, or Harry wants to make 60 biscuits. So all you're going to do here is just compare how you go from 20 to 60. And that is just going to be multiplying by 3, isn't it? Meaning that the amount of flour in grams that Harry will need for 60 biscuits is just going to be 250 multiplied by 3, which is just 750. So the answer is just 750 grams of flour. So I'll just put this here. I'm just going to write 750. And that is it. That is question 16 finished. Okay, so question 17 says there are 200 counters in the bag. 38 counters are red, 52 counters are blue. The rest of the counters are yellow or green. There are the same number of yellow counters as green counters. What percentage of the counters in the bag are yellow? Okay, so this one, what we need to do is work out how many counters there are that are yellow and then write it out of 100 as a fraction, right? Because that will give us the percentage. So firstly, let us figure out how many yellow counters there are in this bag. Now, we know that there are 38 and 52 red and blue counters. So what we can do is add those numbers together. 52 plus 38. Now, 2 plus 8 gives me 10. So I have to put a 0 here and then I have to carry that 1 to this column. 5 plus 3 gives me 8. Now I have to add that 1, which will give me 9. So this will be 90. 52 plus 38 is 90. This is the amount of red and blue counters. To figure out how many yellow and green counters there are, I'm just going to take that away from 200, aren't I? So I'm going to do 200 take away 90, which is just 110, isn't it? Sorry, 110. And this is going to be yellow or green. Now, they've also told us that there are the same number of yellow counters as there are green counters. So to figure out how many yellow counters there are, we're just going to divide it by 2 because there's an even amount. So all we're going to do is just do 110 divided by 2. Now this one isn't too bad because 110 is the same as 100 plus 10, right? So we can just split it like this, 100 over 2 plus 10 over 2, like this. This is 50. This is 5. So therefore, this is just 55. But you could use the bust-up method as well, whatever you like. So this is 55. We know that there are 55 yellow counters. Now, I'm going to write 55 yellows. 55 yellows. Now, the question asks us to work out the percentage of counters in the bag, which are yellow. So what we want to do firstly is write this as a fraction of the total amount. So I'm going to say that in terms of a fraction, it's going to be 55 out of how many? There were 200 counters in total. Now, if I want something as a percentage, all I need to do is write that fraction out of 100. The number that I get on the numerator is just going to be the percentage. So what I can do here is say, well, fine, I've got 200 here. I need to go to 100. That means quite clearly I need to divide by 2. That means I need to divide this by 2. So we just need to work out what 55 divided by 2 is, and I'll do this here. I'll use the bust-up method to work that out. I've got 55 here and then 0.0, just in case it's a decimal. Now, how many times does 2 go into 5? It goes in twice, doesn't it, with a remainder of 1. Now, how many times does 2 go into 15? 2 times 7 is 14. So it goes in 7 times, doesn't it? And there's a remainder of 1 to get from 14 to 15. Now, how many times does 2 go into 10? It goes in 5 times without any remainder. So this is our answer, 27.5. So I'll have 27.5 here. Now, since this is out of 100, this just means that the answer is just 27.5%. So the answer is just 27.5. And that is question 17 finished. Okay, so question 18 says, Naomi has B bags of apples and C crates of apples. There are 5 apples in each bag. There are 28 apples in each crate. Naomi has a total of capital T apples. Write a formula for T in terms of B and C. Okay, so there's a lot going on here. There's a lot of letters. It may look a bit daunting, but what you want to do is just take your time, take it step by step. Now, what are we dealing with? We're dealing with T, which is the total amount of apples, and they either come in bags or crates. Now, we need to write a formula for the total amount of apples in that Naomi has. So what I would do is, well, we've got 2 types of bags or crates, right? Now, firstly, if I start with the bags, right, what do we know? They've told us that for every bag, so 1 bag, we know that there are 5 apples. Now, apparently, Naomi has B bags. So I'm just going to write B bags all the way down here. Now, this letter B can be a bit confusing, right? What I like to do is use examples just to see if I can formulate some sort of pattern. So, for example, we know that 1 bag will have 5 apples, but what would 2 bags? How many apples would 2 bags contain? Well, it's quite clearly just going to be 2 times by 5, isn't it? Which is going to be 10 apples. All right, 10 apples here. How about if there were 3 bags, for example? What would that be? Well, that would just be 3 times 5, which is equal to 15 apples. And then hopefully you can see some sort of pattern forming, right? The number of bags, right? What we do is we just multiply that by the original number, don't we? So we can see here, 2 times 5 gave us 10. We've got 3 times by 5, which gives us 15. So I'll put this here. So we can see that the number in green is the amount of bags, and Naomi has B bags, right? So the number of apples that she would have would be the number B, the letter in this case, and we'd multiply this by 5. And this is just equal to, algebraically, 5b. So in total, in terms of the bags, Naomi will have 5b apples. So that is done, right? We know that Naomi's going to have 5b lots of apples in terms of the bags. Now we've got to do the same thing for crates. So we could say here that, well, from the information given, we know that one crate is just equal to 28 apples. This 2 crates then, well, we just double that number. Again, the pattern will be formulated. Will be 2 times 28, which is equal to 2 times 36. This will be 56. 56 apples, right? And so on and so forth, right? We're just going to do the number of crates times the original amount of apples in one crate. So we could say then, we know that Naomi has C crates of apples, so it's going to be C crates, like this. And all we would do here is just times that C by the 28. So it will be just 28 C apples. So now we have the amount of apples she has for the bags, which are 5B apples. We have the amount of apples she has in the crates, which is 28 C apples. So the total number of apples will just be the amount of apples, which is 5B, and the amount of apples in the crate, which is 28C. So we could just say then T is just going to be equal to the 5B plus the 28C. And that will give you the 3 marks. Okay, so question 19 says, here are the first 5 terms of an arithmetic sequence. We've got -5, 3, 11, 9, and 27. Find an expression in terms of n for the nth term of this sequence. Okay, so I'm just going to write the sequence out one more time. So I've got -5, 3, 11, 19, and 27. Now they've told us that this is an arithmetic sequence, and it's very important to know your definitions in terms of the different types of sequences that they can give you in the exam. An arithmetic sequence is just a sequence that just either increases or decreases by the same amount each time. And if we look here, well, we are at -5 and we need to go to a 3. How do we go from a -5 to a 3? We add 8, don't we? And then here, we can see that we have the same thing here. To go from a 3 to 11, we add 8. And then to go from 11 to a 19, we could add 8. And then 19 to 27, we add 8, and so on and so forth. So we know that this is definitely okay. We know that we expect the number to be the same between each of the different numbers. We call this the common difference. Now, to get the nth term, all you're going to do is, this is very, very simple. So we're going to nth term here. Now, the common difference, i.e. the number that you add each time, you always put here. So I'm going to put 8, and then I'm going to put the letter n next to it. That is the first part of the nth term. 8n, so the number, the difference between the numbers, you put that first and then you multiply it by n. And then what you put after this is where you ask yourself, well, this is the first term here. What would the 0th term be, or the term before the first? Well, to go this way, we add 8. So to go this way, we have to take away 8, don't we? If I want to get the term before it. So we're going to do -5, take away 8. That will get you to -13. And the number that you find here for the 0th term, you just put next to this expression here, -13. So the nth term is just going to be 8n minus 13. And that is how you do all of these types of questions when it comes to the nth term of an arithmetic sequence. And that's question 19 finished. Okay, so question 20 says we need to work out 8.46 divided by 0.15. And it may look a bit daunting because you've got decimals here and you don't have a calculator. But what you can do, just to help yourselves out, is maybe just rewrite each of the numbers in terms of integers. And we know that we can do this because, remember, fractions are equivalent. So if I multiply by a certain number, maybe 10 or 100 or 1000 to get rid of the decimals, that will work itself out. And maybe the fractional equivalent, right? Or the integer equivalent of this fraction may be easier to work with. And I'll show you what I mean. So for example, I've got 8.46, I'll write as a fraction first, divided by 0.15. Now I want to get rid of the decimals here, and I want to make it into a whole number, and the decimal places are in the same position. So what I could do is, well, I need to go 2 units to the right, don't I? That means I just need to multiply by 100. So I'm going to do this top and bottom. And what will happen is that, well, 8.46 times 100, this is going to be 846. And then 0.15 times 100 is just going to be 15. So we know that 8.46 divided by 0.15 is exactly the same as doing 846 divided by 15. But this one is nice because this is just the bus stop method, right? This is a lot easier to work with. So we're going to work with this one. So I'm going to use the bus stop method to work out what this is. So I've got 15, and then I'm going to put 846 in the bus, like this here. Now, firstly, 15, does it go into 8? It does not. So we need to ask ourselves, how many times does 15 go into 84? Now remember, having a good knowledge of your times tables is crucial. So 15 times by 5, you should know, is equal to 75, right? And then, well, 15 times by 6 is going to be 75 plus 15, which is 90. So we can see quite clearly that it will go in 5 times. 15 goes into 84 5 times. So I'm going to put a 5 here. And the remainder, well, how do I go from 75 to 84? It's going to be 9. So I'm going to put a 9 here. And then now I have to ask myself, how many times does 15 go into 96? Well, we can see quite clearly here, 15 times by 6 is 90, right? 15 times by 7 will take you to 105, which is far too big. So we know that it goes in 6 times. So we're going to have a 6 here. And then what would be remaining? Well, to go from 90 to a 96 is just 6, isn't it? So I'll put a 6 right here. Then now we need to ask ourselves, well, how many times does 15 go into 60? Well, you've got 15, you've got 15, you've got 30, you've got 45, and you've got exactly 60. It goes in 4 times, right? So therefore, we can put a point here, and this is going to be 4. So the answer to 846 divided by 15 is equal to 56.4. But remember, 846 divided by 15 is the exact same as 8.46 divided by 0.15. So we can say that this is also equal to 8.46 over 0.15. So then the answer is just 56.4. And it will give you the 3 marks for question 20. Okay, so question 21 says, work out 7 3/8 minus 2 1/2. Give your answer as a mixed number. So right now we have mixed numbers. So what we need to do first is convert these into improper fractions. So I'm going to do this separately. So I've got 7 and I've got 3/8. Now to convert this into an improper fraction, what you do is multiply the denominator by the number at the end or at the front. 8 times 7, right, is 56. And then what you do with that number, you add it onto the numerator. 56 plus 3 is 59. So therefore, this just becomes 59 divided by 8. And we'll do it with the second one, which is 2.5. So we're going to do 2 times 2, right? This gives us 4. And then I add that number to the numerator. 4 plus 1 is just 5. So I get 5 divided by 2. So now we've converted both of these into improper fractions. What I can do is say, well, the question then is just going to become 59 divided by 8 minus 5/2. So what do we do now? Well, remember, we need to subtract these fractions. We can't subtract fractions if they have different denominators. So we need to have a common denominator, which will be the lowest common multiple. Now, we know that we can multiply these two together, and that will give us a common denominator. But as you can see, 2 is a factor of 8, right? Meaning that 8 must be a multiple of 2. So that means that your LCM in this case, or your common denominator, is going to be the LCM of 8 and 2, which is just 8. So I'm going to write 8 here, I'm going to write 8 here. Now this one hasn't changed. This is going to be 59/8 still. Now I've gone from a 2 to an 8. That means I've multiplied by 4. Remember, fractions have to be equivalent, meaning I have to do this times this by 4 too. So I'm going to have 20/8 here. So now I've got 59/8 minus 20/8. Now, because the denominators are the same, I can just subtract the numerators. 59 take away 20 is going to be 39/8. Now, the question asks us to give our number as a mixed number. This is an improper fraction at the moment, so we can't use this. So what we do now to get it back into a mixed number is you ask yourself, how many times does the denominator 8 go into 39? Well, you've got 8, you've got 16, you've got 24, you've got 32, then you've got 40. So quite clearly it goes in 4 times. So you're going to have a 4 at the front. And then the next part is you're going to put this over 8. This is always over 8. What is the remainder? It went into 32. How do I go from a 32 to a 39? It's going to be 7. So the answer is just going to be 4 7/8. So I'll put this here, 4 7/8. And that will be that for question 21. And that will give you 3 marks. Okay, so question 22 says a cube has a total surface area of 150 centimeters squared. We need to work out the volume of the cube. Okay, so firstly, let us get a picture of a cube, right? That's the first thing. Now, a cube is just going to be a 3D object whereby all of the faces are squares. So what I'm going to do is I'm going to draw a cube like this. I'm going to draw another square like this. And then I'm just going to connect these So we've got a cube like this here. This. Right. Now, they've told us that this cube has a total surface area of 150 centimeters squared. Now, remember what I just said in terms of the faces, right? They are all squares, meaning that each face, each area will have to be the exact same, right? Because remember, a square will have all of the sides the same. So what I'm going to do is, remember, we don't know what the lengths and widths are, right? But we know that they are the same. So I'm going to label this X here. I'm going to label this X, and I'm going to label this X, right? These are all X's, aren't they? Yeah? All X's. Anyways, I might as well just label them all X's. Okay. So now we know that each of the sides and lengths are the same distance, x. Now we know that the total surface area of this cube is 150 centimeters squared. And remember, the total surface area are just all of the areas of each surface added together. Now, how many surfaces do you have here on this cube? Well, there are 6 sides, there are 6 faces. So there's going to be 6 areas that we need to calculate. So I'm going to just say that the total surface area, right? We're going to write total surface area, let's say for total surface area, this is equal to the area of the 6 faces. Now, what I'm going to do, let me just rub out these x's because it can be a bit confusing, right? Okay. Now, the question asked us, right, to work out the volume of the cube. Now, this is another thing that you need to remember. The volume of any cube or even cuboid, right, I'll just do another general shape here. And this will be a cuboid now, like this. So it's like this now. And it's the exact same formula for both cuboids and cubes. But remember, a cuboid is a rectangle. One of the faces is a rectangle, right? So if I have the width, the length, and the height, right? The volume is equal to the width times the length times the height. And that is the same for a cube. So in our case, the volume is just going to be equal to these 3 times together. X times by X times by X. And you could simplify this just to become X cubed. So our job is to figure out what X is because we need the volume. And the volume is equal to X cubed. Now, how do we figure out what X is? Well, they told us a bit of information about the actual area. We know that it's the 6 faces, but we can see here that this is actually equal to 150 centimeters squared. Now, as I said before, we're dealing with a cube here. Each face is a square, meaning that every single area is the same. So if 6 faces is equal to 150, then that means we can calculate what one face must be equal to, because we just need to divide that by 6. So what we can do is just work out what 150 divided by 6 is. Use the bus stop method. 6 goes into 1. No, it doesn't. 6 doesn't go into 15. How many times does 6 go into 150? Oh, so it's just going to go in nicely then. And that will be 25 times, isn't it? So I'll put 25 here. 6 goes into 150 25 times. So that means that the area of one face is just equal to 25 centimeters squared. Now, remember, we need to figure out what x is. And we can actually figure out an expression for the area of one face, because if I just grab one of these faces here, I'm going to draw a rectangle like this, or a square, sorry, because we're dealing with a square. We know that the base and the height are both x. So that means that an expression for the area will just be equal to x times x, which is just equal to x squared. So therefore, we could say that the area, which is x squared, has to equal to 25 centimeters squared. So we can say that x squared is just equal to 25. And that means we could figure out what x is. Because if x squared is equal to 25, the way we find x is by square rooting. And the square root of 25 is just 5. So now I have x, right? So that means I can say that all of these distances here are just 5. These are just 5. So then the volume, I'll do it right here. The volume then for this is just going to be 5 times by 5 times by 5, which is just 125, and it will be centimeters cubed. So the answer is just 125. And that will give you the full 4 marks for question 22. Question 22. Okay, so question 23 says the table shows information about the daily rainfall in a town for 60 days. And we've got the column for the rain in millimeters and the frequency on the right. And it says we need to draw a frequency polygon for this information, and it's 2 marks. Okay, so for this one, this is very, very easy, right? All you want to do is whenever you're trying to draw a frequency polygon, you're just essentially just plotting the midpoint of these class intervals with the frequencies, and you're basically going to treat them as x and y's. So I'm going to draw another column like this. And I'm going to call this MP for the midpoint. And this is going to be the midpoint of each of these. And yeah, doing this, we can see quite clearly the middle between the midpoint of 0 and 5 is going to be 2.5. But if you can't see it easily, the midpoint between any two numbers is you just add the numbers together and then divide by 2. So this one, 5 to 10 is going to be 7.5. 7.5. And this one's going to be 12.5. This one's going to be 17.5. And this one's going to be 22.5. So all we're going to do is essentially treat these as our x's and then treat the frequencies as our y's. So we're essentially going to start off with the midpoint, which is 2.5, and we're going to go up to 8. So where would that be? So 2.5 would be right here. 8 is going to be right here, isn't it? So it's going to be this point we're going to plot there, 2.5 and 8. The next one is going to be 7.5 and 24. 7.5 is right here. 24 is going to be 21, 22, 23, 24 is going to be right here. That's the next point we're going to plot. And next point is going to be 12.5 and 13. 12.5 is right here. 13 is, this is 11, this is 12, this is 13, it's right here. Next point is going to be 17.5 and 11. 17.5 is right here. 11 is just one above 10, so it's right here. And then the last point is going to be 22.5 and 4. 22.5 is right here. 4 is going to be 1, 2, 3, 4 is going to be right here. So therefore, we've got our points. Now, once you've done this, all you're going to do is just connect these points with straight lines. So I'll go ahead and do this. I'll do this in green, so it's a different color. So it will be from here to here. And I'll straighten these up like this, straighten this up like this. That's fine. Then I'm going to connect this point there like this, and then like this here. I'm going to connect this one. So I'll connect them shortly. So it's going to be like this. And then the last one is going to be from here to here. Like this here. And this will be your answer. This will give you the 2 marks. And this is a perfect frequency polygon diagram. And that's question 23. Okay, so question 24 says we've got the universal set from 1 to 10. And the set A is odd numbers, set B are square numbers, and for part A, we need to complete the Venn diagram for this information. Now, with these types of questions, what they like to do, which is what they've done here, is they like to describe the set as opposed to actually putting the numbers that would go there. So the first thing that we need to do is actually figure out what the numbers are. So firstly, I've got the set A, which are odd numbers. So the answer, let me put this in blue, sorry. So the actual numbers that will go in this set, right, are going to be the odd numbers from the universal set, which we can see here is going to be a 1, a 3, a 5, a 7, and a 9, right? So I'd put 1, 3, 5, 7, and a 9 here and put commas between them. Okay, that is fine. Now part B, or set B, sorry, I should say, are the square numbers. Now you've got to be very careful here, right? Now a square number is any number that you can square root and you'll get an integer at the end. So for example, I could say the square root of, for example, 49, right? This is equal to 7. Since I get an integer here, that means that 49 is a square number. Yeah, I write SQR for a square number. So what we have to do in our case is just go through the numbers, square root them, and just check to see which ones are whole numbers at the end. So if I do this here, now the square root of 1 is 1. That is a whole number. That's fine. The square root of 2 is not. Neither is 3. The square root of 4, though, is 2, right? That is a whole number. So we can put 4 here. That is definitely a square number. Now, 5 isn't, 6 isn't, 7 isn't, 8 isn't. The square root of 9 is 3. So therefore, 9 is also a square number. And the 10 doesn't have an integer as a square root. So these are the numbers that are square numbers, 1, 4, and 9. Now, I've listed A and I've listed B. Now we can fill in the Venn diagram. What I always do is start with the overlap, the intersection. So what numbers do they have in common? I can see a 1 here and a 1 here. And the only other numbers I can see is a 9 and a 9. So therefore, I know that I'm going to put a 1 here and a 9 here. Now, what I do is I look at the first set and I can see that I've got these numbers 3, 5, and 7, which don't go in the middle, but they have to go in the set A. So they're going to go in the outer part here. So 3, 5, and then a 7. And now I'm going to do the exact same thing for B. There's a 4 here that will go in the outer part of B. So that's done. Now, we are not finished because remember, it's all well and good doing the two circles, the intersection as well, but we have to do the outside as well. And that is going to be the numbers that we haven't used. And we go back to our universal set for those numbers. Now, if I look here, we have used 1. We haven't used 2, so 2 must go on the outside. We've used 3. We have used 4. That was a square number. We've used 5. We haven't used 6, so that will go on the outside. We haven't used 8, but we've used 7. 7 has been used. We haven't used 8, so 8 will go on the outside. And then we've used 9. 9 is there. 10 we haven't used, so that will go there. And this will be our completed Venn diagram, and that will give us the 3 marks. Now, part B says a number is chosen at random from the universal set. Find the probability that this number is in the set B dash. Now, this is set notation. You need to be familiar with this. B dash just means the complement of B, right? In other words, not B. So what numbers are not in the set B? That is what we're dealing with here. Now, if I look here, the numbers that are in B are how many? There's 1 here, there's 2, there's 3, there's 4, there's 5, there's 6. There are 7 numbers that aren't in B. So remember, we're dealing with a probability here. The probability is a fraction, the amount of numbers that we're dealing with, which is 7. And then we're going to divide this by the total number that there are. Now, if there are 7 here, then it's going to be 8, 9, and 10. So it's going to be 7 out of 10. And that will be our answer for part B, 7 out of 10. And that is question 24 finished, and that will give you the full 5 marks. Okay, so question 25 says, the scatter graph shows information about the ages and weights of some babies. We've got the weights on the vertical axis and the age in months in the horizontal axis. And part A says we need to describe the relationship between the age and weight of the babies. So this here is a scatter graph, right? Whenever they ask you to describe the relationship, you just need to state what type of correlation you can see here. And we can see that the graph is going upwards, or the points I should say is going upwards, right? And that actually means, well, as the babies get older, as the age increases, right, so is the weight. So this is just going to be a positive correlation. So what I'm going to do here is just put positive correlation. And you can just say as well, as the age increases, the weight increases too. That's all you need to say for part A, and that will give you the mark. Now, part B says another baby, let me zoom in a bit. Another baby has a weight of 5.8 kilograms. Using the scatter graph, find an estimate for the age of this baby. Now, whenever you see these types of questions, which is always going to come up in a scatter graph question, you need to find an estimate. You're going to draw a line of best fit. So you need to draw a line that best fits these scatter points. So you're just going to draw a line that follows the pattern or the trend. So it'll just be something like this, isn't it? So maybe like this. So something like that. This is fine. This looks fine to me. So now this is your line of best fit. Now let's go back to the question. Question said we need to find an estimate for the age of this baby when the baby's weight was 5.8 kilograms. So all you're going to do is go to the weight, and you're going to go to 5.8 kilograms. It's going to be 5 here. It's going to be 5.2, 5.4, 5.6. 5.8 is right here, just 1 under 6, 5.8. So we're just going to go to our line of best fit, which is right here. And then we're just going to go down to here and see what age that gives us. And that's quite clearly 4, isn't it? So we can set an estimate for the age is just going to be 4 months. And a lot of you will have different lines of best fit, but they should all have they should all have the same trend. So with these types of answers, there's going to be a range, and 4 will definitely be within that range. And yeah, that's question 25 finished. Okay, so question 26 says the price of a holiday increases by 20%. This 20% increase adds £240 to the price of the holiday. Work out the price of the holiday before the increase. Okay, so this is a typical percentage question whereby they give you some sort of increase or decrease. They give you the percentage, and then they also tell you what that percentage increase or decrease actually equates to, right? So if we read it again, the holiday increased by 20%, but this 20% increase adds £240 to the price of the baby. That must mean then that the 20% that has increased the price has to be equal to that £240 because that added the price that was added onto the holiday. So we consider that 20% is just equal to the £240. Now, if we are working out the price of the holiday before the increase, well, that is just going to be 100%. So we need to figure out what 100% is. So we are here, we are at 20% and we need to get to 100%. So quite clearly, how many 20s go into 100? It's 5. So we need to times by 5. So all we're going to do here is just do 240 times by 5 and see what we get. Now, 5 times 0 is a 0, right? So I put a 0 here. 5 times 4 is 20, isn't it? So I'm going to put a 0 here, and I'm going to put a 2 here. And then 5 times 4 is another, 5 times 2 is 10, sorry. And then add the 2, that's 12. So it's going to be 12 here. So it's just going to be 1,200. So therefore, the price of the holiday is just £1,200 before the increase. So that is going to be our answer. Okay, so question 27 says, the diagram shows a solid cylinder on a horizontal floor. The cylinder has a volume of 1,200 centimeters cubed, and the height of the cylinder is 40 centimeters. The cylinder exerts a pressure of 90 newtons on the floor, and we need to work out the pressure on the floor due to the cylinder. And they've given us the formula for pressure. It's equal to the force divided by the area. So since we need to work out the pressure, I'll write this out here again. Pressure, we know this is equal to the force, and they've actually told us that the cylinder exerts a force of 90 newtons. So we know that the 90 is going to go here, and we're dividing this by the area. So we need to work out the pressure, and that tells me that we need the area, because once we know what the area is, we just do 90 divided by whatever the area is, and that'll give us the answer. So how do we work out the area of this cylinder? Now, we're dealing with a cylinder, and they've told us about the volume and the height. Now, you need to know the formula for the volume of a cylinder, which I'll do right here. So the formula for the volume of a cylinder, all right, volume of a cylinder, all right, SIL for short, this is just equal to pi r squared multiplied by h, right? Now, in our case, the reason why it's pi r squared is because of the face here, and it's actually a prism, right? A cylinder is a form of a prism, right? So essentially, we actually don't need to know what the radius is, right? Because all we can do here is just say that this is the area that we're looking for, the area of the face here, which is this circle. We times this by h. So I've got this here, volume of the cylinder. Now, let's look at our formula and see what we know. Now, the volume of the cylinder, they've actually told us is 1,200. And then the area is what we're trying to look for. Remember, it's the area of the face, right? Which we know is a circle, pi r squared, but we don't actually need it. We're just going to call it area. And the height is 40. So we can see here that we've got 1,000 is equal to the area times by 40. So this is just an equation. So we need to divide by 40 to get the area on its own. So it's going to be 1,200 divided by 40 is equal to the area. Now, how do I work this out? Well, 1,200 divided by 40, I can cancel the 0 there, cancel the 0 here. It's just the same as 120 divided by 4. Well, what is 12 divided by 4? 12 divided by 4 is 3, but there's a 0 there, so it's 30. So the area of this cylinder, right, the area of the face is just going to be 30 centimeters squared. So now that we've got the area, we are able to work out the pressure because the pressure is force divided by the area. So I'll just do it here. We know that pressure was equal to the force, which was 90 divided by the area. But we now know the area is 30, so it's going to be 90 over 30. I can cancel this 0, cancel that 0. 9 divided by 3 is just equal to 3. So the answer is going to be 3 newtons per centimeter squared. And that will give you the 3 marks for question 27. Okay, so question 28 says, well, we've got a graph in front of us. They've given us 2 lines. And it says that we need to use these graphs to solve the simultaneous equation 2 minus 2y is equal to x and 2y is equal to 3x minus 22. Now, those two equations are actually the equations of these two lines. And if you look at it, it's actually only 1 mark. So not a lot is required. Now, this topic here is just solving simultaneous equations graphically. And the way you solve simultaneous equations graphically is just by finding the point of intersection of the two lines. So in this case, the answer to the question is going to be the point of intersection, which is right here. We can see quite clearly that that is going to be 6 here. And this one here is going to be minus 2. And 6 is for the x and y is for the minus 2. So your answer to the question is just going to be those values. X is equal to 6, y is equal to minus 2. And that's it. That's why it's only 1 mark. And that's question 28 finished. Okay, so question 29 says we need to work out the value of 4 to the minus 6 times by 4 to the power of 9, all divided by 4. Okay, so with this one, when we look at it, right, it's only 2 marks. So we know we're not expected to actually manually work out, for example, 4 to the power of 9 and so on and so forth, right? And it is a non-calculator paper. So this is just quite typically an index law question, right? Laws of indices, which you need to know very, very well for your exam. So with this one, what I'll do is I'll just start with the numerator. Let me just scroll up a little bit. So it's going to be 4 to the minus 6 times by 4 to the 9, which is what I need to work out. Now, there is an index law that states if I have a to the power of b times by a to the power of c, this is equal to a to the power of b plus c. You add the powers together. So in this case, this is going to be 4 to the power of minus 6 plus 9. Minus 6 plus 9 is 3. So this just becomes 4 to the power of 3. So I can actually write this as 4 to the power of 3 all over 4. Now, what you should know as well is another index law which states if I have a to the power of 1, this is just equal to a, right? So any number can just be written with the power of 1, meaning that I could write this as 4 to the power of 3 divided by 4 to the power of 1. And then now we have another index law problem, right? And there's another rule which states if I have a to the power of b divided by a to the power of c, then we just take the powers away instead of adding them. So in this case, we can actually work this out to become 4 to the power of 3 take 1. Now 3 take 1 is 2, so it just becomes 4 squared, which is just 4 times 4, which is just equal to 16. So the answer is just 16, and that will give you the 2 marks. And that's question 29 finished. Okay, so question 30 says we need to write down the exact value of cos 60 for 1 mark. Okay, now you don't have a calculator, so what you need to rely on is your knowledge of your exact trigonometric values. And what you can do is actually construct a table and you can memorize this for exam. So I'm going to do it here. Now it works like this. You're going to write sine here. You're going to write cosine here. You're going to put a square root like this. And then you're going to put the angles that you can get, which is either 0 degrees, 30 degrees, 60, sorry, not 60, 45 degrees. Next, 60, and then 90 degrees. And then what you're going to do is you're going to start from the number 0, and you're just going to go up in ones. 1, 2, 3, 4. And then what you do when you get to cos is you reverse it. So you start from 4 and you go down 3, 2, 1, 0. And then you're going to write this all over 2. So this is your table here that you can memorize, right? Now, how to get certain values is like this. So for example, let's just say I wanted to calculate maybe the sine of 45 degrees, right? Sine of 45 degrees is right here. So I'm going to write this here actually. Sine of 45 degrees is what we're trying to calculate. Now, in that case, all you would do is just go to that on your table, which is a 2 right here. So you're going to put a 2 here. But remember, there's a square root over it. So it's going to be the square root of 2. And then we're going to divide this by 2. And this will be our answer. Let's do another one. Let's do, for example, the cosine of 60 degrees, right? Or let's do the actual question then. Cosine of 60 degrees will just be, for example, cosine is here, 60 is here. So we have to go to this 1 right here. Now, in that case, we're going to have a 1, but we have to put a square root over it. And then we're going to divide this by 2. So therefore, the cosine of 60 is just equal to 1 over 2 because the square root of 1 is just 1. So it's 1 over 2. So the answer is 1 over 2. But let's just do another one just to really bring it home. Let's do the sine of 90, for example. Sine of 90 degrees. So sine of 90 degrees. Well, if I'm looking for sine of 90, right, sine is here, 90 degrees is right here, so I'm looking here. So sine of 90, we're going to put a 4 there, and then we're going to put a square root over it, and then we're going to divide this by 2. Now, the square root of 4 is 2, so we've got 2 divided by 2, which is 1. So therefore, the sine of 90 is just 1. And I'll get my calculator so we can double check. Sine of 90 is equal to 1. Cos of 60 is equal to 1/2. Our question, I'll move this here actually. And sine of 45, is equal to root 2 over 2. So you know it works. So this is a very good tool to use. So make sure you memorize this for exam. And that's question 30. Okay, so question 31 says the probability tree diagram shows the probabilities that Shayla will work at home or will work at the office on 2 days next week, Monday and Friday. And they've given us the probabilities, right? So the probability that she will work at home on a Monday is 0.2, in the office 0.8, and so on and so forth, right? On Friday, working from home would be 0.7, working in the office would be 0.3. Okay. Now, the question says we need to work out the probability that Shayla will work at home on Monday and work at the office on Friday. Now, this is a probability tree question. Now, there's a couple of things that you need to know, right? When you're dealing with probability trees, right? If you see the word and, that means you just multiply the probabilities together. And then or means that you add. Now there's no or anywhere, so we're not going to use this one today. However, we've got and. So let's look at this again. It says we need to work out the probability that Shayla will work at home on Monday. Well, on Monday, the probabilities are here. If you work at home on Monday, that is 0.2, like this. And then we need Shayla to work at home. We need Shayla to work at the office on Friday. So we work at home on Monday, and then on Friday we're working at the office. So it's going to be this here. And all you're going to do is you're going to multiply the probabilities along the branches because you're working at home on Monday and you're working in the office on Friday. So you multiply these probabilities together. So we're just going to say the probability of, I'm going to write H for home, and I'm going to write and O for office, right? It's going to be 0.2 multiplied by that 0.3. So we need to work out what this is. Now, how would I do this without a calculator? Well, first I'm going to write this out here again. So it's going to be 0.2 times by 0.3. Now, I don't like dealing with decimals. So what I would do is I would convert these decimals into whole numbers. And I can do this just by multiplying by 10. 0.2 times 10 is 2. 0.3 times by 10 is 3. Sorry, I wrote a 3 there. That should be a 10. So this is what it's going to be, right? When we times by 10 on both. And we know that 2 times 3 is 6. But this isn't our answer because we times by 10. So once I've got this, I actually need to go backwards. Now, I multiplied by 10 twice. 10 times 10 is 100. So I actually multiplied this by 100. Meaning to go backwards, I just need to divide by 100. So I'm going to do 6 divided by 100. And that's just equal to 0.06, isn't it? 0.06. So the answer is just 0.06. And that is the answer for question 31. And that is the entire of paper 1 finished. Hi guys, Daniel here. I hope you're doing well. So yeah, we made it to the end of paper 1. And hopefully you didn't find it too tricky. To be fair, non-calculate papers are always slightly tricky. But if there was any topics or any questions that you found challenging, then I'm hoping that this video has helped you understand the topic or question a bit better. And you're in a better position come May. And yeah, thanks a lot for all your support. If this is something that you enjoyed in terms of the video and this is something you think you will benefit from, then feel free to just drop a like, comment, subscribe, share with your friends, anyone that you think would benefit. And yeah, I'll definitely be doing paper 2 and paper 3. So just keep posted on my YouTube channel. And yeah, good luck with your exams in May. You guys are going to do very well. Just make sure you're doing past papers. So yeah, take care. Bye-bye. I'll see you guys soon.